we're gonna have a talk given by Yifei Ma from Amazon AWS AI Lab on modeling trend recommendations, in fact. So actually they combine next item recommendation with time series forecasting in a probabilistic graphical model. Looking very much forward. And the stage is yours.
I cannot find my...
Let me just
Oh yeah, that's
this one here,
yep.
and then you want to go to full screen. Yes. Okay. Don't know, or maybe you can just do it like this. Okay.
No.
Switch here. This is just a PDF. I was shown how to do it with a PowerPoint, but not with a PDF. So you can just click.
Does it work? No, it doesn't.
It doesn't work.
Yeah. Doesn't work. Sorry. Oh, all right. Okay. Awesome. Thank you. Thank you, everyone. So my name is Yifei, and I'm here to present the work from our group, Trending Now, Modeling Trend Recommendations. This is a collaboration between AWS AI Labs and Amazon Prime Video team. So trend recommendation is a common carousel on personalized home pages. On Netflix, there are Trending Now panels. And on Twitch, there are what's hot panels. So these are just two examples, but you can imagine that there are a lot of web pages where you want to use trending recommendations as a subcomponent. So our work tried to formulate these works using some algorithms and definitions. So the challenges in trend recommendations are the following. First, trend recommendation is actually a forecasting problem. Trend recommendation introduces diversity to personalized home pages. And with trend recommendation, users can grasp up-and-coming items before they become popular in the near future. Sorry, there's a typo on the slide. There are a lot of related works in social media domains, such as sensing trend topics, Twitter Monitor, meme tracker, etc. But they're not as popular in the recommendation spaces. Now, the existing solutions in recommendation systems are often heuristic-based. They are often hand-designed rules using hourly click rates, changes in hourly click rates, item category features, etc. Because these are hand-designed, often we lack proper measurements, which could lead to suboptimal solutions. Finally, trend recommendation can be combined with recommender systems. If we just use a pure forecasting model, we may be improved using explicit item features. But with a recommender system, we can also learn latent item embeddings from user behavioral data, and that can improve the performance of trend recommendation. So here are the outlines of our work. First, we want to define trend recommendation objectives. It is a new carousel for items with the highest predicted growth rates in engagements. Then we're going to propose TrendRec, which is a deep Bayesian framework that combines recommender systems and time series forecasting models. Finally, we're going to talk about our experiments. So let's start with the definition. We have to think, what is a trend, right? On the picture, we can see that the red item, which is item B, has a growing trend, and the blue item has a declining trend. So that's pretty obvious, but we can also put it into math. So here, we define popularity to be the cumulative number of clicks for an item over all times. Popularity is something that we can observe. We also have velocity, which is the number of clicks per time interval. For example, we can have a velocity of 1,000 clicks per hour for a particular item. Finally, we have acceleration, which is the changes in the hourly click rates. We're interested in recommending items with high acceleration because we believe they have high growth potentials. It is important to note that popularity is not velocity and it's also not acceleration. In our view, popularity is about the past, velocity is about the current, and acceleration is about the future. So after we define the objectives, we also find the troubles in the measurement of these objectives. That is because acceleration as well as velocity cannot be directly observed. They are the latent rates of clicks. So we decide to pick numerical differentiation at fixed time intervals because it is a rather simple objective. So, but we still have to choose the right time intervals. If the time intervals are too short, we may end up having high variance in the equations. That's because the numbers that we observe are random events, and if we don't wait enough, the noise in the random events could be large. If we wait for too long, we might have a lot of bias because the underlying acceleration patterns could change over time. So we empirically set the interval by the prediction performance of a heuristic method, which we will introduce in the experiments section. And we find that this empirical objective is good enough to compare models from our experiments. So to summarize, trend recommendation optimizes for acceleration, which is the changes in the hourly click rates. We measure the actual acceleration through second-order derivatives in the cumulative popularities. We have to pick a time interval to best approximate the true acceleration values, and we'll next introduce deep Bayesian models to optimize for the acceleration objectives. So now let's move to the model. So the model is a combination of recommender systems and forecasting models. So it's easiest for me to introduce plate diagrams for both of these kinds of models. First, let's talk about sequential recommender systems. This is pretty straightforward to explain. Here, SIT is the observed user history. With the observed user history, we derive a latent user embedding UIT. And we also learn a latent item embedding, VJT. Combined, we can predict the click labels in the future. Similarly, we can have a plate diagram for the time series forecasting model. So here, we just look at the past acceleration patterns for a particular item in the hourly click rates. And we use that to predict the acceleration labels, which is the acceleration in the next time step. We want to combine these two models into a joint Bayesian model where we share the latent item embeddings between the recommender systems and the forecasting models. This is intuitive because then we can say that items who share similar users tend to have similar embeddings and they tend to have similar trends. In our actual implementation, we further simplified the algorithm into two steps. So step one, we just train a regular recommendation model from sequence models, such as GRU for rec. We keep the item embeddings, and we discard the user embeddings. On step two, we feed the item embeddings, as well as the observed user histories, into a time series forecasting model. Here, we pick Deep AR, which is a neural network-based time series forecasting model. Deep AR allows for external features which are considered context variables. Here, we just feed the item embeddings into the deep AR models. There are some additional details about our model, including how we address data imbalance. Our reviewers appreciated that, so that's in our paper as well. So we also consider some baseline algorithms. One baseline algorithm is a Markov model where we just predict the acceleration of the next time step based on the observed acceleration in the previous time step. We have exponential moving average, which is a prediction based on a weighted average of historical accelerations weighted exponentially by the difference in the time steps. Finally, we have a base deep AR model without using the external information. Here we just train to predict the next the next acceleration based on the history of accelerations using a sequence model such as RNN, MQCNN, etc. Notice that DeepAR supports external information in our trend rec model, but we omitted it in this baseline. So finally, let's talk about the experiments. So first, we talk about the metrics for the evaluations. We consider trendiness scores by the growth in the hourly click rates. So this was measured on a relative scale. First, we have the model growth rate, which is the growth rates of the items that the model output. And we look at the acceleration patterns individually, and we sum it up. So that is the model growth rate. We also have Oracle trendiness scores, which is coming from the items with the highest true accelerations from hindsight. Finally, we have random items which generate some acceleration patterns which are used as baselines. So we pick to report the normalized metrics based on the relative positions of the model predictions between the Oracle prediction and the random prediction. We also have a trendiness normalized discounted cumulative gain score, which is defined in a similar way. We did the experiment on 3 data sets with 5 scenarios. So the 3 data sets cover e-commerce domain, movie recommendation domain, and news recommendation domain. On these plots, we're showing how we pick the measurement intervals that yields the largest statistical significance. The plot shows the same Markov heuristic model against the random baseline measured at different time intervals. And from this plot, we can decide that for Taobao dataset, the optimal time interval for measurement would be 3 hours or 2 hours, depending on which scenario you consider. For Netflix, the optimal is 1 day because there's no finer grained data, so the best we can use is 1 day. And for news recommendation, that would be 30 minutes. So here are our comparison results in numbers. Of course, we want to say that TrendRec outperforms all baseline models, and you can see the largest numbers from the last row of the results. We can also see that we can observe performance improvements from TrendRec, and it is associated with the quality of the recommender systems in different domains. For example, Taobao represents e-commerce domain where recommender systems are gives the best predictions, and you can see the biggest gain in the forecasting performance as well. Finally, we can see that deep learning-based models significantly outperform heuristic models. This shows that there are nonlinear patterns in trend predictions, so at the very least, we should try to use neural networks for trend recommendations. Here are the conclusions of our talk. Trend recommendation is a common carousel in personalized homepage designs. There are existing solutions, but they often use heuristic methods without clear objectives. We define acceleration in the hourly click rates to be the targets for trend recommendations. Our proposed trend rec model also utilizes latent item embedding features from recommender systems. We have empirical results which support the wide applicability of trend rec algorithm. For future work, we can consider other methods for trend modeling, especially using continuous time features. We used numerical differentiation, which is a discrete view of this click patterns, but we can also try to model the system as a point process, for example, a temporal point process. We can also think about a single-stage Bayesian model, which may lead to better recommendation and forecasting performance. That's all. Thank you.
Thank you. So I see we have a couple of questions already on Slido. First one, any reason it has to be a sequential model for the first step to obtain the item embeddings?
Okay, that's an interesting question. I guess you have a bit of flexibility in the choice of the recommender systems. Our reviewers also recommended other models. Sequence model tend to give better results, I would say. We just picked one, yeah.
Actually, also want to ask one, since
Yes.
in general trends are very much dependent on the user group, right? So, for instance, users with different cultural backgrounds, countries, and so on, differ strongly. So, does your model account for that, or could you integrate this information, or are you planning to do so?
So trends are about the items; they're not about the users. But user information will definitely influence the recommender system, which will eventually influence the item embeddings. We also have reviewers talking about different localities of these items, and we believe this can also be influenced through the recommender system.
Thank you. Would it also make sense to include the user embedding in the trend rec model?
That would be a personalized trend recommendation model. I think that would be a very interesting future direction as well.
There is one question about fresh items. If you need to train item embeddings with GrooveRec, can you get good item embeddings for fresh items?
I think it depends on different scenarios. So I think one thing we observed was that if we have e-commerce and movie recommendation, the items are more established. For news items, there will be more fresh items, and some external features like release time would actually be very powerful in the trend predictions as well.
So I have a question.
Any question here, the audience?
It seems to me that there could be competitive effects in trends. So there's only so much attention, right? So if one item is trending, that may interfere with another one trending, especially if they're about the same thing. And so I'm wondering if there is actually, a threshold, like how similar is too similar to maybe an existing item where that would change what the trend you would see. So if they're say there are two videos about the same current event, let's say, probably between them, the two of them might have a strong trend, but they would be splitting the attention.
I think you're talking about the sort of the diversity in the recommendations. I don't have a solution on top of my head, but I think this is a very interesting observation. Thank you.
There is one more.
Hi, thank you for the talk. I have a question related to the movie recommendation. So for fresh items that say new movies that just got launched on the platform, and then it's likely the item embedding is not as stable, and then might be just initialized a little bit. And then would it still to get a trend prediction for those titles?
So the answer is yes and no. Here you can say this. You can see this is a Bayesian model. So the item embeddings are definitely influenced by the user behaviors, and therefore, if this new item has some established user behaviors, they're not just released on the same day, then you can massage this model into getting item features. But if this item is released today, or if it hasn't been released yet, then you would need external features as well.
I see. Thank you. And do you have any comparison with the model that not using or not heavily depend on the item embedding, instead just rely on the hourly click rate?
Yeah, that would be the deep AR model without using the item embeddings, and we can see improvements. The improvements depend on the domain. For e-commerce, the improvement was the largest.
Okay, thank you.
Yep.
Thank you very much. The speaker again.
Thank you.
So